Mars born from the solar nebula. Like Earth accreted dust and gas, eventually forming a terrestrial world. Its smaller size significantly impacted its evolution. Early Mars likely possessed a global magnetic field generated by a molten iron core similar to Earth's. This shielded the atmosphere from solar wind erosion. But it ceased billions of years ago. Without a magnetic field, the solar wind relentlessly stripped away Mars' early thicker atmosphere. Water vapor and other gases were lost to space, leading to a colder, drier climate. Olympus Mons, the largest volcano and highest known mountain in the solar system, is a shield volcano formed by hotspot volcanism over billions of years. Its immense size highlights Mars' lack of plate tectonics. Valles Marineris, a vast canyon system, stretches thousands of kilometers. While not formed by water erosion like Earth's Grand Canyon, its origin is linked to tectonic stresses related to the Tharsis bulges. Orbital images reveal extensive networks of dried-up riverbeds, lake basins, and outflow channels, providing compelling evidence for a warmer, wetter Mars in the distant past. Mars possesses permanent ice caps, composed primarily of water ice and carbon dioxide ice. The northern cap is larger and less layered than the southern cap. Dark, narrow features cold, recurring slope. Lineae SL appear on steep slopes during warm seasons, suggesting potential transient briny liquid water flow. Mars' current atmosphere is thin and composed primarily of carbon dioxide. Its low density and lack of ozone make the surface vulnerable to harsh solar radiation. Dust devils, common on Mars, are swirling columns of dust that can grow much larger than terrestrial. Dust devils, they contribute to atmospheric mixing and dust transport. The Martian surface is rich in iron oxides, giving the planet its characteristic red color. The presence of perchlorates in the soil poses challenges for future human missions. Curiosity rover explores Gale Crater, a large impact crater containing Mount Sharp, a layered mountain that preserves a record of Mars' environmental history. The Perseverance rover is searching for signs of past microbial life in Jezero Crater, an ancient lakebed and river delta thought to have once harbored habitable conditions. Scientists are looking for biosignatures, evidence of past or present life, such as organic molecules, unusual isotopic ratios, or fossilized microorganisms. A Mars sample return mission is planned to bring samples collected by Perseverance back to Earth for detailed laboratory analysis, offering the best chance to definitively answer the question of life on Mars. Radar data suggests the presence of subsurface water, ice, and potentially even liquid water beneath the Martian poles. This could provide a resource for future human missions and potential habitats for microbial life. Mars has two small, irregularly shaped moons, Phobos and Deimos. They are likely captured asteroids, and their origin is still debated. Human missions to Mars face significant challenges, including radiation exposure, the thin atmosphere, extreme temperatures, and the psychological effects of long-duration space travel. ISRU, the use of Martian resources like water ice and atmospheric carbon dioxide, is crucial for sustainable human missions. It could enable the production of propellant, water, and other essential supplies. Terraforming, the hypothetical process of transforming Mars into a more Earth-like environment, faces enormous technological and ethical hurdles. Whether it's even possible remains uncertain. Future missions to Mars will focus on continued exploration by robotic rovers, the return of Martian samples to Earth, and the eventual establishment of a permanent human presence. Planetary protection. Protocols are in place to prevent forward contamination of Mars, with Earth-based microbes ensuring that future searches for Martian life are not compromised. The prospect of colonizing Mars raises ethical questions about the impact on any potential Martian life, the environmental consequences, and the rights of future Martian settlers. Mars represents humanity's best hope for establishing a permanent foothold beyond Earth, offering the potential for a second home, and ensuring the long-term survival of our species. Mars, with its ancient mysteries, potential for past or present life, and the challenge of human exploration, continues to captivate our imaginations and drive our quest to understand our place in the universe.